Hello everyone, this is Physics 101. This lesson is on thermal expansion. So if you have ever observed the design of roads, you would see that there's actually gaps in between them. Or if you want, if you would see railroads made from metals, railroads where the train moves, so you would actually see gaps in between these structures. So engineers designed them because when it's daytime, these materials actually do expand. So when these materials expand, you don't want them to be cracking into each other. And also, these railroads, you don't want them to be swinging into other directions because they wouldn't fit in in this region. So this phenomenon is called thermal expansion. So microscopically, if you would look at the structure inside, for example, in this metal is made up of molecules, and when you apply heat in those molecules, you are raising their kinetic energies, so they will sort of bump in more to these walls, causing the material to actually expand. So this is very evident when you expand, when you heat up, for example, a gas. So gas have very far molecules apart. So when you heat a gas, the container will actually expand proportional to the amount of heat that you give into the gas. So thermal expansion is also experienced in solids. So how do we calculate how much expansion happens when you apply a certain amount of heat? So first, let's consider a rod here, and it has a initial length L naught. Okay, so the change in length of this rod, let's denote delta L, should be proportional to the change in temperature that you apply to it. So it should be proportional to the amount of heat. Of course, this rod will change temperature, so it should be proportional to the change in temperature of the rod. So I'll write this down as also the change in length should be proportional to the initial length of the rod. So if you have more, if you have a longer length, of course the change in length should be longer. So combining these two proportionalities that we observe, the change in length should be proportional to change in temperature times the initial length. So this proportionality constant, actually we shouldn't use this alpha, because if we assign a proportionality constant alpha, in order to sorry. In order to convert this proportionality equation to a real equation, this alpha is the coefficient of linear expansion. So a higher coefficient of linear expansion would mean that the object will change in length much greater when you give it a change in temperature. And if an object has low coefficient of linear expansion, it wouldn't change length much given a change in temperature.